The second talk today is a pleasure and honor to introduce Steve Reiss to you. Steve is a professor at Bern University in the States, and there's two things I would like to say about him. The first one is that Steve is something like a forerunner in many things. Steve developed environments like the desert environment, the field environment, the peak environment. These are things that probably don't ring a bell to you, but if you have done something with soft visualization in the last 25 years, those are fundamental environments. And now he's doing code bubbles, which is something really, again, ahead of its time. And the second thing which I find noteworthy about Steve is that as opposed to many other computer science professors, he actually writes most of the things himself. Like, he programs a lot. So Steve, all yours.
Thank you. Good morning. Now you know the extent of my German. Okay, so, code bubbles. Okay. This way, right? Yes. Okay. He said I do programming a lot. Why? Programming's fun, right? That's what I do for relaxation. I love it. You know, that's why I do so much of it. However, most of my students come and tell me that programming is difficult. People tell me that too. I don't know why. It seems very easy to me. So what we need to do, we're supposed to make it easier for them, right? That's what researchers are supposed to do. And the IDE, the development environment, is supposed to help in doing this. It doesn't really. You know, we had this question, and we had this discussion earlier. What's wrong with Eclipse? There are lots of things wrong with Eclipse. But it's better than nothing, which is why everyone uses it. First of all, it's file-oriented, which is great. You happen to program files. We're programmers. We don't program in terms of files. We program in terms of tasks. We have something we want to do. We want to use code. We want to write code, or we want to fix something. What is that a file we're working on? No, it's a whole set of files. It's a chunk from this file here. It's a chunk from this file. Another chunk from that file. It's documentation from the third file. It's a bug report from someplace else. It's notes. It's email messages we're getting in. It's lots of different things that correspond to our task, and it's not file-oriented. What happens then when you have something like Eclipse, it's very inefficient to use. You have to, because you're working in terms of files, because you have all these fixed windows and things like that, you're spending a lot of your time doing navigation. I've seen numbers from 40 to 80% of your time spent in Eclipse is doing navigation rather than doing real work. And you really have no sense of context. What are you working on? Well, you keep going back and forth, and as programmers, you have to keep everything in your head. And some of us are good at keeping everything in our head, but most students don't. They can look at what's currently there and not go beyond that. So what do we have to do? Okay, third thing. Inefficient use of screen space. I started with 2 monitors back around 1990. I'm now up to 4 monitors on my main machine and 7 in my office. Right now I've been up to 9, but I'm down to 7. I need 4 for programming, especially if you're using something like Eclipse or just straightforward editing and things like that. The others help. It's a very valuable resource. If you've ever done programming, you realize this very quickly. Eclipse is not particularly good at making use of that resource, especially if you have multiple displays, multiple screens, multiple machines, things like that. So what we're trying to do in code bubbles, first we're trying to make programmers more efficient. We reduce navigation, give you the context you need, reduce the you have to remember, things like that. Second of all, we're trying to provide an intuitive environment, make programming, make the environment match what the programmer thinks it should do. We're trying to support all aspects of development, because you're not just writing code, you're doing lots of other things while you're doing software development. And overall, we're trying to make programming easier and make it fun. I like having fun. So I'm supposed to give a demonstration next. So let's see how this works. Okay, here's code bubbles. And before we get there, let's show the program we're going to be working on. Okay, this is a little toy you can get. It has a base you can put magnets on, and it has a pendulum that has another magnet on it that swings freely between those magnets. And this is just simulating it. So what we want to do here, I'm a UI person, so I get annoyed with some of these things. What's wrong here? Well, two things. First, I want the color to be red. I don't like blue and green together. I don't know why. Second, all these plus and minus signs aren't centered. And they should be, right? So you have to fix those things.
That's the 3D effect you see.
Yeah, that could look at it that way. I better stop this or I'll eat the whole machine. So here we have code bubbles. Make sure we have it all visible. Is that all visible? Yes. Okay, some things. First of all, it might be a little. Here's the main area of code bubbles. It might be a little hard to see, but there's a gray area up there. Can people make out the difference between blue and gray? This is sort of the overview. So instead of just having this portion of the display, this little blue rectangle represents this portion of the display, and you can see I have a whole big space I can really work in. Actually, that space goes on forever, or as long as the Java will let me make it go on. Both horizontally and vertically. It'll extend beyond that as needed. So you have lots of space. Now, you can use this in various ways, so I can work here, and then if I get interrupted, I can move over there, and I can come back to where I was, and things like that. Second, you have workspace. You have a little bar on top, which we'll use to label the overall space. And third, you have a view over here for searching and giving you context if you need it. Now, you can get rid of that if you want. So we wanted to change the color to red. That's the easiest thing to do. Well, how do you find the paint routine? Well, you can search through everything, but the easiest thing we can do here is just right-click and bring up a search box. And if you know Java, you know that any drawing has to be done in a routine called paint component or something like that. So we'll just type in paint here. And it turns out we're lucky. There's only one component with paint in the name. So we'll select that. And what it's going to bring up isn't the whole file that contains. I'll get back to this. It's actually just the function, paint component. Moreover, it's trying to make it fit in the screen as much as possible. So it's done, let's see, go here. You can see it's made it fit pretty much square if you can. You can make it longer if you want. And notice that when it cuts it off, it makes it look just like you typed it. It uses the Eclipse indentation rules or whatever your indentation rules are to do the reflow. It tries to make that natural. The other thing it's done is it's elided some information here. So that inside the 4 there's a comment, and the comment body of the 4 is elided. We don't need that. If we want it, we can look at it just by clicking on it. Or if we don't want it, we can click it up, click it away. Very easy, very intuitive. Windows easy to resize, as you saw. Now what we want to do is to change the color of the, not the magnets, but to the pendulum. And there's a set color red. I don't know what that's doing. Nothing was red there. But that's not what we want. We want to be able to draw the pendulum. So we want to click on that. And then we can just bring up the bubble for draw pendulum by just F3ing on that and bringing up that bubble. Notice here that they are surrounded by a colored border. This means they're grouped. You can ungroup them just by moving it away, or regroup them by putting it together. You can label groups, so this is drawing, if you want, and then remember the groups later on. You can move the groups as a whole, rather than as individual bubbles. And these can work in terms of those. And here's draw pendulum, and here's the color blue. So we can just change that to red. These are full function editors with all the Eclipse functionality you'd expect in an editor. They have code completion and syntax highlighting, error highlighting. So if I go in here and type errors, I'll get error messages. And you can see the context of the error. Get it there as well. They have undo. Yeah, so they're fully functional editors. And you can go there. It's compiled now. We can run it if we wanted to. We'll go to that later. We have other functionality we can go to here. Let's see. There's set color here. If we click on set color and say go to that, it knows it's not. Okay, I don't have. It's not online. Couldn't find the documentation. Okay. I should have gotten it online. It should bring up a documentation bubble at that point. Essentially Java doc for just that function, and you can move that around so you can get those bubbles in. Let's see, what else can we do? We can click on Get Magnet and do F4 on that, and this is all the places where Get Magnet is used in the system very quickly. You can see them that way. See this, and if I want to pull that out, do that, pull that out, and then I get rid of this. Middle clicking on the box or escape will make the box go away. If you don't like it going away, you just click on this thing and it comes back. So fully functional environment, lots of capabilities there. You can use it for real programming. So that gives you some sense of what Code Bubbles is all about. I showed most things. So let's figure out where we were. And wait for the screen, and we'll get back to our talk. That's the Okay. So, I started, we demoed this project 2 years ago. I'm an academic. Why am I still working on this? Couple things. One, I believe in it. And if I believe in it and I think it's going to be very useful, I program myself. I want to use it myself. Well, nobody else is going to implement it for me, so I'm going to implement it myself, which is what I did. Two, there are some interesting problems that come up. And a lot of the programming environments research, a lot of the tools that people want to do can be plugged into this environment, and it often can be more natural in this environment than some kludge facility like Eclipse. You can figure out ways of doing it that really match the way the programmers work this way. So some of the things we dealt with here. First of all, we had to build the environment, and we had to architect it in some way that was flexible and could handle all the things we wanted to do in the future. We didn't put it into Eclipse per se. One of the things you find out when you're working with Eclipse is if your program aborts and it leaves Eclipse in a funny state, and you lose everything very quickly. We didn't like that. We have a very little piece in Eclipse. Everything else is external. I'll show later on why this is a good architecture for what the types of things we want to do. We have a message bus, going back to some of the old environments they talked about, field, that lets these two talk to each other. And we let Eclipse do all the grunt work of the environment, all the parsing, debug control, and things like that. So we don't have to duplicate all that. But we wrote the front end using this and talk to the user. Okay, some of the other problems. Code creation. The original Code Bubbles was not particularly good at creating new code. Unfortunately, we as programmers tend to create code all the time. I don't know why. Things just keep getting bigger, though. We have to be done in context. Programmer cares things like where the method goes. You can't just stick it at the end all the time. You want it at the right place in the file. And you also have to do it right. It has to look correct. It has to be formatted correct. It's supposed to have a comment in front of it. That has to be there. All of the things you need to do. We've tried a whole variety of solutions to this. Flexible templated insertion. Some would like Eclipse, but we have our own templates. Manual budding and extraction, so you can just keep typing at the end of a function, and then you can extract that out into its own bubble, so you know exactly where it's going to be. We have intuitive insertion commands, so the search box on the right, or the one you prop up, you can insert after any method there, and some of the other tools have the same thing. We're working on automatic creation, automatic insertion, and trying to place it logically. Next problem we came into, what does undo mean? Sounds simple, right? You want to undo. But I have all these different bubbles. I'm treating them as different editors. If I undo over here, you shouldn't undo over here, even though this is the last place I typed something. I'm in this editor. It should undo in this editor. You have to have undo at the function level. Unfortunately, every now and then you'll get command dependencies. You can have multiple bubbles up on the same function. If I'm typing here and it's the same editor, same function that's being displayed here, it has to undo in both places, or I have inconsistencies. So we have command dependencies. There are also global commands which you have to worry about. What we end up doing is undoes the edit in the current bubble. We track dependencies automatically between the bubbles. And it'll also undo on any dependencies, or undo in the other bubbles back through where the dependency was, so there were edits there. Next problem you come into, and this never came up with the original one, because nobody ever used it for 3 or 4 hours at once. But you know, this is essentially 1 hour of display, and you can see the screen looks somewhat crowded, but that's only one little part of the whole area that I've created. Now, usually what happens after 4 or 5 hours is my whole top display is full of bubbles. I just create and create and create. So how do you manage complexity like this? And there are a number of problems that come up. The original methodology, and you saw when we popped up a bubble, it just popped up on the right there, where we created it. Well, if I pop up a bubble from here and it pops up on the right, it's going to move all these other bubbles around. And it's going to distort whatever you set up in terms of your display. So we have a variety of ways of getting around this. Group-aware positioning, so this is a group. You pop up a bubble here, it's going to pop up to the right of the group, not to the right of the bubble where it popped up. 2, we give the user control. So the bubble will pop up, and for 2 seconds, the user can move it around wherever they want and won't move anything out of the way until they're done moving it. And that seems a very natural way of handling this. We've tried some various features of automatic layout. We tried just cleaning up the screen type layout, and we're working on automatic layout, which is semantically aware, so it can put, say, the field definitions towards the top, and functions that call each other to the right. Okay, so those are some of the simple problems that we came into that we fixed in trying to come up with a real version of Bubbles that works for real programming. And we're using this on itself and on a number of other systems, so we are using it for real programming. There are a number of enhanced features we've worked on, debugging, providing context and collaboration, and I get to do another demo, debugging demo. Okay. So I'm here. It's not there yet. So if I want to debug this and see if we change the color to red correctly, I can just go up here and tell it to start a debug session. I happen to have the right debugger there, and I can just start it. And it does the normal Eclipse things of saving, compiling, and Eclipse takes a while. Pops up a bubble. Now I have other bubbles I can show here. Now you notice that some of these bubbles are fixed on the screen and others are not. The bubbles gives you the option of having fixed bubbles if you want them. I can also make any of these float, so if I wanted this one to actually float, I could just make it floating. And now it'll move around with the display. Okay, so what we have here is it shows you where you are. I can step. I can just run it actually. Let's go back here, just quick, and we can set a breakpoint in the drawing just by clicking there. Now we can go back to the debug and continue. And here it came out below. Why did it come out below? This has gotten, I'm a professor, I ask questions. It came out below because it's in a different thread. You have to handle multiple threads here. If it was the same thread, it would come out to the right, indicating it was the same thread. But here you're in the drawing thread. So multiple threads tend to come out below the original threads. But you can still get, if I then do I can do a step into here. And it puts it to the right, and I can continue stepping. Goes away, now it steps in, gets the other one, the third one, and now here I get into inches, whatever call that was. You can see it tries to make logical use of the display. It gives you full control of debugging. You can look at values. So here I can just point to X and it'll show me there what X is, or I can look here. This is the stack display. Get X here. Actually, what I can do is I can pull this frame out into its own bubble rather than the whole stack as a bubble. Or I can pull this variable out. And just have a bubble showing that value. I can create bubbles like this. Now these bubbles have a green background. Colors are not that good on this display. If I want to remember what this value was at this point for later on, I can just go in here and say, freeze the values. And now it's going to remember those values. They're not going to change as the program continues execution, but that bubble will stay there. And moreover, I can go and explore what these values in some depth. It's not just whatever was listed in the bubble at that point. So it's actually kept track of the values to some depth there. And we have other things here that you can see. One is a debug history, showing what we've done, again colored by thread. And I can go to any point here and show the source at that point, what bubble I was in, what function I was in, or I could show the values at that point in time. And go back and forth, and here's where it started from. So you can track your debugging session, go back and forth that way. We have performance, how your program is run, where it's spending its time. And here, most of the time is spent creating physics vectors. I don't know this program that well, so which will become obvious later on. So we can now stop the program running and go back to our talk, and this time let's start the talk where we left it off. It might make more sense. Okay. Couple things, the debugger layout, debugging is complex, the sessions are long, layout of the bubbles of all the stacks and things like that's important. We have a number of layout heuristics. This is very different from what was done in the original code bubbles. It's also different than what Microsoft has done in their implementation, Code Canvas, of code bubbles. I think the heuristics, from what I've seen, from lots of use, get it about right. Sometimes they're a little bit off, but they're close. You also have problems. What happens if the user goes and you can edit in those bubbles in the debugger. Those are completely editable. You can also go to the next bubble. What happens if the user brought up the bubble it's going to step into? Should you use that, or should you pop up a new bubble when you do that step? Well, we try using it. There are a whole lot of questions like that. How do you make this be natural? How do you make it be intuitive to the program? Next thing we do is we do something I call active debugging. And the idea here is we put a little piece of code in the user program, running in its own thread, making use of multiple cores on your machine, talking back to code bubbles and to Eclipse so it can get information. The program talks to Eclipse. We just talk to Eclipse that way, and we actually do. This lets us do a whole bunch of things. Now, it gives us the performance monitoring. So this little thing is checking out where you're executing by doing stack sampling occasionally, every millisecond or so. Very low overhead, but it's giving me performance numbers, so I want to know what's happening in the debugging session. It'll tell me. If you ever get to a deadlock, it'll tell you right away, within a millisecond, rather than you waiting and having to figure it out later on. It realizes that. It'll tell you what threads are actually doing, so it'll tell you whether threads are doing I/O at this point, or doing system calls while your program is running, so you get some sense of how the program is running while it's going, much more detailed than you would otherwise get. When you get to a breakpoint, it can tell you what the thread that broke and all the other threads were doing for the past couple of seconds. All the stack samples that it got from those threads. So you can get some sense of what led up to this breakpoint. And it gives you that in a window you can go back and forth on to see the time. And we're working on this for a number of future applications as well. Okay, so that was the debugging. Next problem we came into across was context. You think of code bubbles, you can eliminate files completely. No. Programmers like files. I like files. They provide context for your code. They give you an organization of the code. You might want to go back to it. They give you the organization when you go back, understanding what's related, what's not. There are all these other tools out there that want files as well. And every now and then you find people who actually go and read code. I know if the students give me something, that's what I'll tend to do, is read the code in the files. And I can understand it and see where they're coming from that way. Function location in the system, file location in the system, all these things are important. The organization is important, so is readability. How do you provide that in this environment where you're only showing little snippets of files? So we have, I can give another demo. a variety of tools here. And let's see if I can remember them all. Let's go back here. Okay. I can't go back and I'm going to quit either, probably, right? Okay. Not to be quit. This is turbo. That's wrong. Let's quit that. That's probably what's hanging everything. Let's go here. It's not a successful demo unless you find bugs, right? Wonder what's hanging. Let's see. Okay. Notice it puts you back right where you were. The debugging excluded. It doesn't remember debugging sessions, but that's probably on purpose, or it is on purpose. Okay, so what can we do to do context? Well, one, we can go and this is in board. So we can go to board. And we can bring up the whole class of board. And you can get a context of the file this way. Notice it's elided all the content, all the methods of the function, things like that. You can also do this. This is just the class, which is useful when you have nested classes and things like that. We can also bring up the file, which should look pretty much the same, except it has all the prefix information in there. On file and class bubbles, it tries to make it the right size. It doesn't try to make it square. I guess with a file, we decided to write that at the high level, but you can get all that back. You see what's going on. So those are the obvious types of things you can use for context. We have other things we can bring up here. We can bring up a viewer of what's currently in this display area. So, there we are. And this tells us that the bubbles we have here in this local area are from two files. And if we go into one of the bubbles, it'll show us where they are in the file. Here, let's see. Let's move the display around. You can see where your context, you can get context information there. Now this will work, it looks at basically what it thinks your local area is. If you want to be more explicit, you can go up here and create a working set or a task. You can make that as big as you want. And now this will show what's in this task. So you can make those explicit. You can name the tasks, you can save them, and bring them back later on. All types of things you'd expect in an environment like this, where you're very task-oriented. So that's the second thing we can do. Third thing we can do is we can bring up an overview of the file, which essentially gives you a one line per item. It includes things like comments, which you can't see here. They come up here as well. And here, if I wanted to insert something here, I can go and insert a comment before, after, insert fields. Again, insertion is very easy. I can use this to move things around in the file, reorganize my files. I can move things between files. It's a very high-level view. So that one. I think those are most of the overviews that I have. Gives you some sense of what's there. Oh, the other, yeah, there is one more. here. Thanks. So we also can show the graph, and here we can determine what type of classes or methods you want to show, and you can go and show what edges you want. So if you only want to see the hierarchy, get rid of everything else. Still have allocates. There's the class hierarchy. If you want to see what allocates what, get that. You can go and explore, get context, explore your classes using a view like this as well. Okay, so now let's see. We can add. Continue the show. I think that's just F5. We're back. Next, I'm told that software development is collaborative. People collaborate with doing software. I even know how to do that at times. What does this mean, though? Everyone has their own meaning of what collaborative software is. So some people think collaborative software is pair programming. Where you have two people sitting at the screen, and one's programming and the other's commenting on it. Others say it's just teams of programmers working on a project. And that can be done in a variety of ways. They can be local, or they can be geographically dispersed. They can have a common source base, something like you used to do with RCS or CBS. No, CBS is common. CBS is common source as well. Or you can have a global source, individual sources like you have with Git, and somehow you merge them together with some fancy tree hierarchy there. So we want to support collaboration in code bubbles. We wanted to support full steam. How do you do that? Now, how do you support all of these things? Okay, we provide a whole variety of mechanisms. Simple ones start with programmer communication. So we start with chat bubbles. You can chat using all the various protocols that are out there. I think we've covered most of the major ones at least. You can chat to anybody else. It's all done within the environment. The environment remembers what's going on. It has a history, chat histories, so you can save your chat sessions for later bringing up as bubbles. You can send and receive working sets. So I can take that area I colored there in the past demonstration and send that to somebody else, and they can bring it up on their display, see it in their source. So you can collaborate that way. Show people what you're working on, what you've done. You have educational chat. Well, yeah, we have educational chat. That's a fun thing. We want students to be able to talk to TAs and chat with TAs. But we don't want the students to know what the TA's handles are, for obvious reasons. If you've ever been a TA, you don't want the students talking to you while you're trying to do your own homework, or your own assignments. You're a student too. So we have a mechanism whereby students can anonymously talk to the TAs. We have email support. Not only can you send these working sets through chat, you can send them through email and load them back in from email very easily. You can also include them in other places, save them in other files. Okay, we have notes. I didn't show this. Probably what's going on. This is so here, I can go here. If I want to attach a note here, I can. Well, first of all, I can just bring up a node. Give it some screen space. So I can create a node, and then you can type into this. That's probably why things didn't work. Okay, the other way I can create a node is I can go here and say, here, create attach new node. So I can attach a node to that line of code. Now this attached node is permanent. Both of these nodes are permanent. This attached node is permanently associated with the code. The annotation is it's a little yellow thing there you can't see. You can on the screen. That will stay there even if I remove the node. And somebody else who brings up this environment from my workspace, actually it's shared across workspaces, will see that node annotation there, and they can click on that and bring up the node themselves. So you can share notes this way, attach notes permanently to code as a way of doing collaboration. have all that capability. Next thing we did is we're supposed to be scientists in the university. And one of the things scientists do is they keep logs. So I have a stack of notebooks, it's probably about this high right now, of research logs that I've kept over the years. Why shouldn't programmers do this? It has lots of utility for programmers. You can go back and understand old code, you can understand the motivation you had there. You can go, somebody else wrote a log while they were writing their code, you might be able to understand what they were doing and why they were doing it. You have to make it presentable. One problem here, though, is if you've ever been a programmer, programmers won't do any work. They're concentrating on their programming, they're not going to do anything else. So how do you make an interface here that gives you this type of information without making the programmers do anything? And we've tried to do this with what we call the programmer's log. And here. So here, let's move this. Background. So you notice there was I can always hit F2, and when I started when I started first doing the demo, it popped up a dialog box somewhat like this. You notice that I had a blank screen, empty space, and I popped in my first bubble. I must be starting to work on something. It prompted me for, tell me what task you're working on. And it knows the current tasks. So if I was going to go to change task, it would know what the tasks were that I've worked on here. Remember those. And here I can add notes. I can make it very easy. Just hit F2 to get this. You can add a attach note. I can attach a screenshot as well. There we go. Done. And then later on, if I want to see what was going on, I can just say show the programmer's log. And it lets me choose what information I want to see, whether it's by task or by class or relative to a specific method, and how I want it ordered, and then it pops up the log. And here's the attachment I just added. And notice it added a lot of other information. It knows whenever I open that thing, whenever, a function, whenever I edit that method, what methods I went from and to. It has all the information. It can display whatever you want there. It's all stored in the database. It can be a common log among all the programmers on a team, or it can be an individual log. It can merge logs. But we tried to make it so that we have that capability for doing collaboration. Next thing we wanted to do was share source. This is our original environment for sharing source. Very easy thing to do is just add another version of code bubbles. Talking to the same message bus, talking to Eclipse. What happens here is I can type in this editor. If I'm editing a method, it'll go here and it'll edit. Actually, Eclipse is where everything's stored. And it will send a message out and it'll be updated here. So what I end up with is two screens which are kept in sync in terms of the source. So if I edit one, it'll immediately show up in the other. Is this useful? Well, maybe if you're doing pair programming, this would be useful, because you can see what the other person's doing. But you need other things there. What I like using this for, though, is I said I have 7 displays. Unfortunately, they're on 3 different machines. And I can run code bubbles on all 7 displays, or on all 3 machines, typing this way, and work on the same source. So I can use all 7 displays at once for programming, and have Cinerama, Cineramic programming there. But you have to go beyond that if you really want to do collaborative work this way. And what people are talking about these days is working in the cloud, putting the environment in the cloud. Why? Well, it's accessible from everywhere. You have all the compute power of the cloud. I want to run lots of test cases. I can use everything there. It's platform independent. I can run in the cloud on one machine. I can display it on another. Code bubbles will do that anyway with the previous setup. Well, you have a number of problems here. How do you set it up? How do you make it work? And how do you get the necessary security and privacy? You go talk to a company. They're very wary of their code getting out for some reason. So the various models you can have, this is what we started with in terms of the environment. And one thing you can do is you can put everything in the cloud. And just make this communication link, use BNC or some other screen sharing protocol, and then you can display it there. And it'll sort of work if you have a fast enough connection and you don't worry about things like the Mac uses different keystrokes than Windows or Linux do, because you want to use star rather than control, and things like that, and performance, graphics performance. So that sort of works, but it's not the ideal environment. Another thing you can think of doing is just running Eclipse in the cloud and putting code bubbles on your local machine. Here all graphics is here, Eclipse is here. This should work fine, right? Well, the unfortunate thing here is code bubbles every now and then wants to actually access a file. Where the files reside, they reside here. Code bubbles can't necessarily access them easily. So what we ended up doing is splitting code bubbles in half. We're actually running two versions of code bubbles. One that's sitting in the cloud that doesn't put up a graphical interface, and the other that's sitting here that does put up a graphical interface. And so this is the client, this is the server, and the client, it just checks, every time it wants to read or write a file, it checks am I a client, and if so, it goes and does it by asking the server to do it for it, and send the information back, or it sends the information to the server to save it. Now to make this work, I wanted to run this at home, actually. And I didn't want the VPN into work. And people care about their code being shared over the internet, and I'm going to have to go over the internet. So all we did there is we took the message bus, and we made the message bus work over the internet using encryption. So there's a little thing here, a little servlet that you can talk to, encrypt it, and then send it to this, and these two will talk to each other. So now I can have a client sitting at home or anyplace else with just an internet connection, and this is fairly low bandwidth, talking to Eclipse and the server running in the back end, and I can do my programming that way, and have Eclipse and have my environment run in the cloud. Okay. Next thing we had to do was extend the environment to other tools. We've been busy. Testing. I'll get another demo. So, see if we can break it again. Okay, so testing tools. You want to support testing. We support, since this is Java, we support JUnit testing. We can bring up a test window. It finds, it goes, it's actually running as a separate process. It goes out, it finds all the things, it runs the test for you, tells you the status. It's actually a lot more intelligent than this. You can get information about the test, so here's the failing test. It'll tell me why it failed. You can read that. I can read. I can use this test to bring up the source. I wrote 2 copies of the source. And see what's going on. I can use this test to actually start a debugging session for that test. So I can debug that particular test. It'll set everything up and let me debug it. It also is quite smart in that it knows, it does coverage of these tests, both block coverage, so statement coverage. It does call coverage and branch coverage. So it knows all code that's being used by each of these tests. And as you edit code, it gets messages through the message bus about that. And it'll change the colors here to indicate these tests are now out of date and should be rerun. And then you see that, and you can just show the pending test, show the ones that need to be rerun, just show the failed test. You can run them in. This will run in one of 2 modes. It'll either run on demand, or it'll run automatically in background whenever a test is out of date and compiles correctly. All the files it uses compile. It'll rerun it automatically at that point. This is why you want it in the cloud. So we have those type of capabilities there as well. Okay, so this is the setup. We actually have a separate utility, separate process that's running here. It puts a little bit to do the coverage in the application. It can run multiple applications at once. It just talks to code bubbles into Eclipse where it needs to through the Mint interface. Now when you're running in the cloud, all of this exists in the cloud. So this testing runs in the cloud as well. And these can be run on multiple machines or multiple processors as you need to. JUnit base, and we've covered all of this. But we're also adding support now for making it very easy to create new tests. that will encourage programmers, especially students, to do testing. We can make it easier than that. Okay, version management. We want to do version management as well. Various version management systems. We let the user check in, check out, provide the user with the necessary information. We have a scheme that uses another utility that can run in the cloud. It notices what changed. It notices when you save files. It can automatically, it interfaces to Git, or right now it does Git, CVS, and SVN, because those are the three that I happen to be using right now, but it's fairly easy to add others to that set. It does something else funny. What I want to know as a programmer is what other people are working on, so when I bring up a bubble, it can tell me somebody else has edited this bubble. And I'm probably going to have a conflict later on. But I don't want to do all the registration and everything else to this. I just want this to work automatically. What it does here is it'll encrypt the information about all the diffs from whatever my core is, and send that over the web into a data store. And the only people who can decrypt it are people who know this particular project. But when it does that, it gets back all the other people's changes that have been saved that way. And it can then, by querying the different versions in Git, compute all the lines that have changed and display as an annotation that these lines have been changed by somebody else, and give me information about that before I edit the function or while I'm editing the function. So I can get that type of information immediately and not show any of the code, not store any of the code, and with no setup. Okay. So that's what I talked about. Okay. Okay, so future tools and directions. This obviously isn't complete. I'm using it now for all my day-to-day use. I've actually switched after 20, 30, 20 years, 30 years of using my own environments to use my own editor and so forth, to using code bubbles almost exclusively for my code development. We've done a code search project, and we want to integrate the code search into this. We want to make it work for other languages. We're looking at Python right now as the first extra language. That adds various questions. So, you know, you have this bubbles represent functions. What happens if it's interactive? What happens if your files not only have function definitions in them, but have computations? How do you represent that? How do you organize that? You know, I bring up this, how do you keep the context correct? Doing UI building. Eclipse isn't particularly good at that. And even the ones that are good aren't particularly good. We want to do it right. We're going to do it. JML and other specification languages, bubbles for those. I like to, as you said, I'm doing software visualization. I've always done software visualization. I want to show pictures of my data structures, show what the user, show what I'm looking at so I can get a good intuitive sense of what's going on there. I want to automatically create a working set, so if I start changing a function, I want bubbles to be able to bring up all the things and other things that need to be changed for me as other bubbles, so I have them there. So if I change an interface, it can show me all the definitions of that interface. Actually, F3, go to definition, goes through all the implementations rather than just the interface implementation. And step into steps over system code. So we've done a number of intuitive things there. Screen layout I talked about. One of the things I'm big at in my other research projects, try to visualize what's going on at runtime in the system. So I'm going to incorporate some of these visualizations of behavior, not just the performance, but real understanding of what's going on in programmers' terms there. Incorporate flow analysis and provide feedback there. Other languages of web application environment, deal with all the languages that are involved there. In addition to missing features, there are a number of new directions. There are a number of missing features. Configuration editing, project editing. We haven't, Eclipse has